Okay, dear students, here we have a quick revision of motion graphs. So we will discuss here few points, and these are the points here: distance time graph, speed time graph, and practical examples. So these few things we have to discuss here. The first of all is your distance time graph. So as far as the distance time graph, you have certain uh, uh, points to remember. Key principles. What are key principles? Simple thing is that gradient of the distance time graph is speed. And when we are talking about the gradient, so if you have the steeper slope equals higher speed, it means that if you will have a steeper slope, then you are representing the higher speed. Then, as far as the graph interpretation is concerned, horizontal line, when you are talking about the distance time graph, so be careful. Horizontal line means the line is parallel to the time axis and the body will be at rest. Yani description of the body, description of the state of the body will be the stationary. Then if you have the sloping up situation, then it means that the steady speed. And when we have the upward curve, it means that body is accelerating. Similarly, if you have downward curve, the body is decelerating. So we want to show a few things here. Here you have the core rule, gradient is the speed. So simply you can say and see that when you will calculate the gradient, basically you will calculate the speed. So gradient is simple, rise and run, and this is the ratio of these two will be the speed. On a distance time graph, the vertical rise represents distance and the horizontal run represents time. So what you have, therefore, the gradient calculates exactly how much extra distance is traveled every second. And you know that when we are talking about the definition of speed, so V is equal to what? S over T or D over T. So simply you can say that D is the rise and T is the time which is run. So the ratio of these two is giving us the speed. And obviously the shape of the graph, as you can see here, this will be the shape of the graph when the body has a particular value of speed. Why? Because the slope throughout the graph is constant. Here you can see that a line rising 10 meters on distance, 10 meters on distance, scale for every 1 second on the time scale yields a steady speed of 10 meter per second. Yani if you have a situation like this कि आपके पास जो डिस्टेंस कवर्ड है वो मिसाल के तौर पर कितना है 10 मीटर्स है और उस पे जो टाइम पास हुआ है उसको अगर आप देख रहे हैं तो वो अगर आपके पास जो है वो कितना है 1 सेकंड है तो आप कहेंगे कि जी हमारे पास जो है वो स्पीड कितनी है 10 मीटर पर सेकंड है। अब इसको आप यूं भी समझ सकते हैं कि मिसाल के तौर पर आपने कहा कि जी ये हमारे पास जो है वो एक डिस्टेंस है और उस वक्त एक ये टाइम है। उसके बाद हम यहाँ कहीं पहुँच गए, एक टाइम ये है और एक डिस्टेंस ये है। तो ये जैसे जैसे डिस्टेंस बढ़ता जा रहा है टाइम भी बढ़ता जा रहा है और जो कैलकुलेशन हमारे पास आ रही है वो अगर हम देखें तो ये ग्रेडियंट जो हम निकाल रहे हैं राइज और रन से, इसको हम कैलकुलेट अगर कर रहे हैं तो वो कितना आ रहा है 10 मीटर पर सेकंड आ रहा है। फिर यहाँ पर आपके पास जो है वो एक अगर आपके पास कोई एक बाकायदा बॉडी मूव करती है फ्रॉम वन पॉइंट टू अनदर पॉइंट और ग्राफ आपको इस तरह से नजर आता है तो वो असल में आपको क्या शो कर रहा होता है। डिस्टेंस टाइम ग्राफ की बात हो रही है, ये ध्यान में रहे। So here you have a situation. The coach travels at a steady, slow speed. The distance increases gradually. So what is happening in this case? The distance is increasing gradually and obviously the time is passing. So this line shows the velocity or speed, and obviously the slow speed. Why we are using this term slow speed? Because in the next stage, somewhere here, what is happening? The coach moves faster distance from the starting point, increasing rapidly. Why? Because the slope over here in this region is greater than the slope in this region. So that's why you will say that the coach now moves faster. So the steeper graph, and you can say the body is moving faster. Then here you can say and see that throughout this region there is no change in the distance, or simply you can say the like suppose you have a traffic jam, and what has happened over here, the coach is forced to stop. डिस्टेंस फ्रॉम द स्टार्टिंग पॉइंट डज नॉट चेंज, यानी स्टार्टिंग पॉइंट से मुराद क्या है, ये यहाँ से डिस्टेंस जो है वो चेंज नहीं हो रहा, और यहाँ से लेके यहाँ तक जो है आपके पास डिस्टेंस सेम रहता है थ्रू आउट दिस टाइम। तो आप कहते हैं कि हमारे पास जो है वो कोई डिस्टेंस ही कवर नहीं हुआ, तो इसका मतलब क्या है कि स्पीड जो है वो हमारे पास कोई नहीं है। जब स्पीड कोई नहीं है तो इसका मतलब है कि बॉडी रेस्ट में है। तो ये जो है वो रेस्ट की सिचुएशन को शो कर रहा है। So this is what we have as far as the complete journey is concerned, or the description of this motion is concerned. यहाँ पर देखें कि अगर आपके पास जो है वो कोई इस तरह की सिचुएशन है कि यहाँ से आप जो है वो मूव करना शुरू करते हैं, और एब्रप्टली आपके पास जो है वो चेंज आता है इसके स्लोप में, तो इसका मतलब यह है कि ज़ाहिर है कि जो स्पीड है वो एब्रप्टली चेंज हुई है, और जाहिर है कि वो एक डिस्टर्बिंग सिचुएशन है, कंफर्टेबल सिचुएशन नहीं है। जबकि अगर आप इस ग्राफ को देखते हैं, दूसरे ग्राफ को, तो आपको लगता है कि यहाँ स्लोली एंड ग्रेजुअली जो है वो स्पीड इंक्रीज होती है, और उसके बाद फिर जो है वो आहिस्ता आहिस्ता जो है वो बॉडी स्टॉप हो जाती है। तो ये एक जो ग्राफ है इसको ध्यान में रखें कि अगर आपके पास जो ये आपका पॉइंट है वो एब्रप्टली चेंज हो रहा है, यानी यहाँ से एक ग्रेडियंट है और उसके बाद फिर अचानक दूसरा ग्रेडियंट आ जाता है, इसको ख्याल रखिए कि ये असल में यहाँ से आ रहा है, यहाँ से भी दिखा सकते हैं आप इसको, और जाहिर है कि ये भी आपने दिखाया है कि यहाँ पर हमारे पास जो है वो कोई डिस्टेंस नहीं था, यहाँ तक हम आए, उसके बाद फिर एब्रप्टली जो है वो यहाँ पर स्लोप चेंज हुआ। तो ये जो सिचुएशन है वो एक डिस्टर्बिंग सिचुएशन है। एंगल्ड एजेस imply instantaneous changes in speed. In reality, this would result in an impossibly violent, uncomfortably comfortable rise. We use these straight lines to simplify speed calculation. इसका मतलब क्या है कि जब हमने इस तरह के ग्राफ्स देखे, क्योंकि हम ये कई दफ़ा देखते हैं कि ये इस तरह के ग्राफ हैं, तो फिर क्या है, तो हमने कहा कि भाई असल में तो सिचुएशन जो है वो ये कंफर्टेबल है, लेकिन हम जो ये वाला ग्राफ देख रहे हैं ये हम आसानी से कैलकुलेशन के लिए देख रहे हैं कि भाई हमने कहा कि भाई एक पॉइंट सपोज के ओ से और इस पॉइंट तक यानी y1 तक जो है वो हमने एक स्लोप निकाल लिया, यानी एक स्पीड निकाल ली, और y1 से y2 तक दूसरी स्पीड निकाल ली। अदरवाइज क्या होगा कि जो एक्चुअल सिचुएशन है वो यहाँ आपको नजर आएगी कि यहाँ पर जो है वो आपको मुस्तकिल तौर पर एक चेंज होती हुई सिचुएशन नजर आती है, और यही एक कंफर्टेबल सिचुएशन है कि आहिस्ता आहिस्ता स्पीड को इंक्रीज किया जाए और फिर स्लोली एंड ग्रेजुअली स्पीड को कम किया जाए। ये याद रखें कि यहाँ पर जो ग्रेडियंट है वो स्पीड को शो कर रहा है, लेकिन आपको यहाँ पे एक साफ चीज़ जो नज़र आ रही है वो ये है कि दोनों सूरतों में जो ग्राफ है वो आपको ये शो कर रहा है कि आपका डिस्टेंस जो है वो कॉन्स्टेंटली इंक्रीज हो रहा है, और यहाँ तक वो इंक्रीज ही होता रहा। स्पीड जो है वो कम ज़्यादा होती रही अकॉर्डिंग टू द स्लोप ऑफ द ग्राफ एट ईच एंड एवरी पॉइंट। जैसे मैंने आपसे कहा कि हर पॉइंट पर आप स्लोप जो है वो फाइंड आउट करके और इसकी स्पीड निकाल सकते हैं इस पॉइंट पर, लेकिन डिस्टेंस बहरहाल इसका इंक्रीज हो रहा है, और इस पॉइंट पर पहुंचने के बाद उसका डिस्टेंस कांस्टेंट हो गया है। तो दिस इज वेरी इंपॉर्टेंट। In the physical world, speed changes gradually. An upward sloping curve indicates the vehicle is actively speeding up, यानी acceleration हो रहा है, while a flattening curve indicates slowing down, यानी deceleration हो रहा है। तो अब आप क्या कह सकते हैं कि आपके पास जो रीजन है वो क्या है कि यहाँ तक जो है वो आपके पास मिसाल के तौर पर एक्सेलरेशन होता रहा, और इस पॉइंट के बाद आपने देखा कि बॉडी जो थी वो डिसलरेट हुई और आहिस्ता आहिस्ता यहाँ पर वो जाके रुक गई, स्टॉप हो गई। तो सी रीजन इज द रीजन वेयर द बॉडी इज नॉट मूविंग एट ऑल। तो ये सारा जो है वो हमने यहाँ पे देखा, और ये जो मैंने आपको यहाँ पे पॉइंट बताए थे उसको एक्सप्लेन किया गया। अब इसमें जाहिर है, ये आपको पता ही है कि इस केस में जब आप डिस्टेंस टाइम ग्राफ बना रहे हैं तो क्या वेरिएबल्स हैं। तो आपने कहा जी एक वेरिएबल हमारे पास जो है वो डिस्टेंस है, जिसको हम वर्टिकल एक्सिस पे लेते हैं चूंकि ये डिपेंडेंट वेरिएबल है। और एक वेरिएबल हमारे पास टाइम है जो इंडिपेंडेंट वेरिएबल है, यानी टाइम गुजर रहा है और उस टाइम के पास होने के दौरान वी आर जस्ट मेजरिंग द डिस्टेंस। सो व्हाट एक्चुअली डिपेंडिंग distance is depending on what? On time. So this is what we have as far as the two variables are concerned. Next few points here, when you will go to the speed time graph. So what are the principles here? As far as the key principles, yani key information which you are getting when you are taking speed time graph or reading speed time graph. So first point is the gradient, which is giving you the acceleration of the body, because acceleration is the rate of change of velocity. So this is what we have. As far as the area under the line or curve is concerned, this will give you the distance covered. Then here you have the situation as we have discussed before as well, that if you have the change of velocity divided by time, so basically what you have, this is nothing but rise over run, yani gradient. So when you are actually getting the gradient, you are getting or calculating the acceleration. And this is what we have. The steepness of the line tells you how much extra speed is gained every second. In every second, what is happening in this case? In one you have suppose 4, in two you have 8, in 3 second you have 12 meters, in 4 you have 16 meters. So what will happen? 15 to 20, you will have here the gradient. You can calculate the situation that the gradient is giving you the acceleration. Gradient of speed time graph is giving you the acceleration. In the graph, the line rises by 4 meter per second on the speed scale of every 1 second on the time scale. The steady acceleration is exactly 4 meter per second square. Now the simple thing is that each time you have 4 rise and 1 second is the run, so 4 meter per second square. But basically when you will go for the calculation, you will do in this way that your final speed is 20 and your initial speed is 0, and your initial time and final time, and you can write that here we have these values like we have 4 sorry 5 and 0. So 20 divided by 5, this will give you a complete picture, and this is what you have. So 4 meter per second square is your acceleration. Fine. Then here you have another example where you are starting from zero velocity and up to 10 seconds you are moving, and obviously you are moving with the increasing speed. And what is happening at point 10, you have attained a speed of 30 meter per second. Then from 10 to 20 second, the speed remains constant. And after this 20 second up to 25 second, you can say that speed is again decreasing and becoming a zero at 25th second. So as far as the peak velocity is concerned, so simply you can say that the line crest at a maximum speed of 30 meter per second. Yani the maximum speed attained by the body is 30 meter per second. Over here, again, as you will consider the gradient of the graph, so you can say and see here that 30 meter per second is the value of the speed, and 30 is the maximum speed, minimum is 0 at this stage, and time is 10, and the time 0 at the initial stage. So 30 divided by 10 is giving you 3 meter per second square. Again, as I said, that when you are considering this part from say A to B, B to C, C to D, So for C to D part, you can say that at C you have maximum speed 30, and at 25th, at point D, 25th second, you have velocity 0. So V minus U divided by T2 minus T1, and basically again you are calculating the gradient. So V is 0. Initial velocity is at this stage is 30, and obviously the time is 25 minus 20. So over here you have minus 30 divided by 5. So this is nothing but minus 6. So this is what I have written here. This is minus 6 means the body is decelerating. So this is the deceleration phase. Constant phase, accelerating phase, and decelerating phase. So this is what we have as far as the speed time graph description is concerned. As we had just discussed that is in speed time graph discussion, the second rule is the area and the distance traveled. So simply what we have discussed on a speed time graph, the total distance traveled is physically represented by the geometric area under the line, yani under the curve. So what we have here, this is your triangle, the area of the acceleration, yani this is the area where the body is accelerating, but basically this is area under the curve of the speed time graph. And you know that as far as the triangle is concerned, the area is given by half base into height, and the calculation gives you 150. So this is nothing but 150 meters. On the other hand, when you will come to this area, here you have a rectangle, and for this particular thing, you know that when the body is moving with a steady speed, yani the speed is constant, so which is obviously 30 and 30 meter per second, you can say. So how you will calculate the area is very simple. You have here this value, and the time is from 10 to 15. So 30, and here you have 5. So 30 multiplied by 5, 150. So the total distance covered, if you will consider the whole area, will be 150 plus 150, yani 300 meters. So this is what we have as far as the area under the curve is concerned. Okay, so here you have the interpretation of the graph when you are considering the speed time graph. So again, as I have already explained, this horizontal line in this case shows the steady speed, sloping line changing speed, and line at zero car stops. Line at zero means when you have this situation that the car is moving somewhere here. I can show you, or if it's not here, it's not here, not here. So like suppose in this case, we can draw a line which is very simple, and you will say that the line, if along the time axis, so this you have meter per second, but the line is somewhere here. This line shows that the velocity is 0. Remember this thing that if line is not lying along the time axis, but the line is somewhere here, both are straight lines, but this line shows 0 velocity, v is equal to 0 meter per second, but here you have a value of suppose 10 meter per second. So be careful of these two facts. As far as the velocity time graphs are concerned, we have already discussed these points that the speed in a particular direction. Velocity time graph, what is showing you? Speed in a particular direction. Why? Because the definition of velocity is nothing but speed in a particular direction. So this is what we have as far as the speed time graphs is concerned. Okay. So if you will compare these two graphs, so simply you can say in case of your distance time graph, in case of your distance time graph, if the line is parallel, then as I said that this will be the situation parallel to time axis, obviously, then it means that the body is not moving, is standing at one particular distance from your original position. So a flat line means distance is unchanged, changing, and the body is stationary. On the other hand, if you have the same shape of the graph in case of speed time graph, then what will happen? A flat line means speed is unchanging. The object is traveling at a steady or constant speed. In this case, it is 15 meter per second. So this is what you have as far as the comparison of these two graphs are concerned. Here again, you have certain comparisons, like if you have the distance time graph and you have the horizontal line, so the body is stationary at a particular distance. The body is standing simply, it's not moving at all. But as I just explained, that in case of speed time graph, you have a steady speed. Yani the body is moving with constant velocity and the velocity is fixed and you have a particular value. If you have a straight diagonal line in case of distance time graph, so simply you will say that the gradient of this line is giving us the speed. So simply we can say that the gradient is constant. So constant distance gained means steady speed. On the other hand, when you are talking about the speed time graph, this straight line, and you can say simply that the steady acceleration, because over here the gradient is constant, means gradient of your VT graph is nothing but acceleration. So speed, constant speed gain, any speed is increasing but constantly. And what is this particular thing? Gradient, and the gradient will give you the acceleration. In case of your distance time graph, if you have curving upward curve, so what will happen? You know, as we have discussed, that the gradient here is showing you the speed, and the speed is constantly changing here because the gradient is constantly changing. So it means that the body is accelerating if you have a distance time graph, and the gradient is constantly increasing. So simply you will say increasing distance with increasing distance per second means the gradient is increasing with increasing rate, and this is nothing but the acceleration. So this is very important. Here again, as we have already discussed, that in case of your velocity time graph, the gradient is giving you the acceleration. So if here you have the gain or increase rate of speed, it means that the acceleration is increasing, acceleration is increasing. In our course, this is not our, you can say, domain. We need not to discuss in detail the increasing acceleration. But this is very important, that if you have the distance time graph and you want to know the acceleration, so you have to check that what is the increase in the gradient, because gradient is velocity. So if you have, suppose, this velocity u, over here you have another velocity, so there will be a change in velocity, increase in velocity, and this will give you the acceleration v minus u divided by delta t. So this is very important to understand. Last but not least, if you have a situation of the practical examples, so what practical examples you have? Then suppose you have the express train, so capable of high speeds and gentle acceleration. So what you have here, the express trains are moving with high speeds and has a gentle acceleration thing. Bus journey, in case of bus journey, what will happen? Rapid speed changes, yani the frequent acceleration and deceleration. So you can say that the bus journey is a bit, you can say, sort of uncomfortable ride. And why? Because the acceleration is frequently changing. The body is sometimes accelerating and then abruptly decelerating. So bus journey is not very comfortable. When you will talk about the marathon running, so simply you can say that varying speed and stops, and then average speed calculation. So for average speed calculation, what you have to do, as we have already discussed, that you have to calculate the total distance covered and the total time. So simply you will get the average speed. Fine. So whenever you want to calculate the average speed, you have to consider the total distance and total time. So this is what we have as far as a brief explanation of your speed time graph and distance time graph is concerned. If you are new on my channel, subscribe this channel and like this channel if you have understood what I have discussed here. और अगर आपको ये चीज़ पसंद आई है तो इसको लाइक करें, शेयर करें ताकि दूसरे दोस्त भी इससे फ़ायदा उठा सकें। मिलते हैं इंशाल्लाह अगले वीडियो में। टिल देन अल्लाह हाफिज़।